Hi, hello everyone. Welcome back to my YouTube channel. This is your Vignesh from your Mr. Vignesh Tutorials. So, in our previous lectures, we discussed about physics subject. In physics subject, we discussed about force and all. We discussed two lectures. So, today, without any delay, we discuss about physics lecture 3 of unit 2, which is nothing but force, work, energy, and power. Okay. So in last class I think we have discussed about force, Newton's pressures, okay, and units also. So in this lecture we are going to discuss about and we have also discussed about free body diagram and some example, right? So in this video we are going to discuss what is work and what are its dimensions, units, and some examples also. Okay, so work is our topic today. What do you mean by work? Directly before going to the definition, I want you just think about the word work. In general, office people or school people, whatever or any work they are doing. In general, work means like we people use in day to day life, right? Like I am doing lot of work, I am doing work there, I am doing work here, I have work, I am so much busy. Will they know what is that work? Whether you are doing really work or you are assuming that it is a work. Let's think for a while, pause it the video and think what is that work actually is. Okay, I hope you all got some point. Okay, let me tell you that. Now, work is nothing but it is related to the force only, but in a systematic form, such that it has to do something. Thing is, it has to do, then only like you are doing something, that there should be some result, then only you are doing, like there is a work. Got it? Let's see what is that. In physics, we define the product of force and the displacement. The product of force and, let's say, distance. To make it simple, the product of force and distance moved by the object by that force is known as work done. Okay, so work done, work is denoted by the word W, which is equal to F into S. This S is dot product. So this dot is not into, simply dot product. Like we can say Fs cos theta. Okay. Work is a scalar quantity or vector quantity. Work is a scalar quantity because we have a dot product here. It only have magnitude. It doesn't have any direction. What is a scalar quantity? A scalar quantity has only magnitude, but a vector quantity has magnitude as well as direction. So work has only magnitude. Only magnitude will be there, but no direction. No direction. So it is a scalar quantity. It is a scalar quantity. Now Fs cos theta. What is this F? What is this S? Now this is a product of magnitude of force applied on the object and the distance. S is a distance moved by the object by that force, and cos theta. Theta is the angle made by the force and the direction which it is moving, that is known as the theta. Let's say for example there is a freely falling body. Okay, there is a freely falling body and which it started with initial velocity 0 and it gains with some final velocity. This is the surface, and on which some Fg, gravitational force, which is equal to mg, equal to weight, is acting over it. Let's say the mass of the object is, let's say 1 kg, and let's say g equal to 10 for our convenience, as it is a problem as example. So what is the force acting that on that body is nothing but mass into acceleration is 10 Newton. 10 Newton is acting in downward direction and its direction is also downward direction. So theta here is nothing but 0 degrees. The force and the direction in which it is moving, the object is moving, both are aligned, so in the same direction, so angle made by them in between them is 0. So theta is 0. Now work done by the gravitational force is nothing but force done by applied by gravitational force into distance mode. Distance mode maybe let it be h or s. We know s equal to ut plus half a d square. We know s equal to ut plus half a d square. From there we can calculate s. So f into s and cos 0, theta is 0, right? So cos 0 is 1, so it will be f into s. What is f value? We know 10 Newton. What is s value? We'll see here. S equal to u is 0 because freely falling body, so ut will become 0. Then half. Acceleration is positive or negative? It is plus g because any freely falling body or anything you have plus g. If it is moving in downward direction, acceleration due to gravity is plus g. If it is moving in upward direction, acceleration is minus g. Because the force is acting in downward direction, so in that direction acceleration is positive plus g. If it is moving in upward direction, force is acting in upward direction, so acceleration is negative minus g. So here we have to take plus. So s equal to half gt square. Okay, let's say the time taken by the body to fall is 2 seconds. Okay, so half into g is 10 into 2 square, so 20. So the distance moved is 20. So I can write 20 here. So it is 200. What is the unit of work? There is a question mark. I am not writing the unit. I will tell you what is the unit. Before telling the unit, we got the magnitude as 200. Let's say for our convenience now Newton second, because not second, Newton meter. Sorry. For our convenience, let's say Newton meter, because the unit of force is Newton, the unit of distance is meter, and cos theta doesn't have any unit as it is scalar quantity. These two are vector quantities, so we got some units. A scalar quantity also has units, but cos theta is just a ratio format, no, it doesn't have any unit. So as of now, Newton meter is a unit. Newton meter can be coined as work, can be coined as, actually that unit I can tell in energy format. When we come to energy topic, I will be telling that unit. As of now, the unit of work is Newton meter only. Okay. I hope you understood what is work and what is the unit of that, and how we derive that work. What is the work done on a freely falling body? Example. We'll cover some more example. First, note it down. It's a very important example. As of now, it can be applied in lot of problems for your MSAT, mains and JEE advanced as well. Take a screenshot of it. I'll tell some more examples on work done in the same lecture. Okay. Okay. Now let's see some other examples of work. Okay, let's take the previous example. I have told the free body diagram for the force applied on a body, and you can see that force resultant force in the previous video. If you want, I'll link that video to this video in the comment section or description. Okay, see that force will be some Fx is 180 Newton and Fy is some 50 Newton we got, right? So we get some resultant Newton. Let's find that what is the theta. We get theta equal to tan inverse of 50 by 180, which is nothing but 5 by 18, tan inverse of 5 by 18, and we have magnitude root over 50 square magnitude F net t square plus 180 square. So we get some value. Let's say, for example, let's say here we get A Newton. The force, resultant force is magnitude is A Newton. Let's say here angle is, let's say, theta equal to x degrees. Let's say x degrees. Now we got resultant force, we got this one. Now we should also find the distance to calculate the work done. What is the distance? It is moving from this point to, let's say, here is the ground, it is touching the ground, it is moving this much distance. How to calculate this distance? You need not calculate the distance. That distance will be given in the formula. Let's say the distance is S. The distance covered is, let's say, S or H or D. Let's say, let us keep the distance as D only. It covers some D distance. Okay. Now, what is the work done? Is nothing but Fs cos theta, right? As we know the formula Fs cos theta, work done. So it is equal to F is A Newton into S is D. Cos theta is, what is the theta? X. So cos X. So this is the worked out example. I am not giving the final answers. That is your homework. You do that solving and get the answers. If you have any doubt, mention in the comment box. So AD cos X is our ultimate solution for the work done, and the unit is, you already seen, Newton meter. So Newton meter is a unit of that work done. This is one kind of example for a freely falling body. Now I will tell you one more example. See, look carefully. I'll tell you one more example. Now, there is a lift, elevator or lift. There is a one person standing in that lift. He is going from third floor to, this is second, this is first, this is ground, let's say. He is going to third floor to fourth floor. Lift is at third floor, he is going to fourth floor. Now, let's say this has system. My system consists of lift and person. Okay, let's say lift, weight of the lift, okay, is nothing but, let's say, 1000 Newton. Let's say weight of the person, I am directly giving the weight, that means force applied by the gravity is nothing but, let's say, 60 kg. Okay, is the mass of this person. We don't know. Okay, we'll find the weight of the person. Now I am asking, if a external pressure is applied in this direction, I am applying the external pressure to the lift in upper direction, that is let's say 2050 Newton. Let's say 2050 Newton, sorry, let's say 1050 Newton. I am applying 1050 Newton. I am applying on this system, in upper direction. So he is asking what is the work done by the gravitational force, is asking. So we have to find the net force and the distance moved, and also what? And also we have to the distance between each and every floor is, let's say, 12 meters, or let's say for our convenience 20 meters, let's say. Okay, 20 meters is the distance between each floor. Actually it won't be that much, but let's say, okay, or 20 feet you can say. 20 meter is very long, or you can tell like how much. Okay, in meters we have to take, no, let's say it will be like some 2.5 meters, let's take. Okay, this is good, no? It is practical also. 2.5 meters is the distance between each and every floor. So distance we know, force also we have to calculate. Now let's calculate F net. F net is nothing but difference between F of applied force, external force, and F of gravitational force. What is gravitational force? Fg is equal to weight, gravitational force on lift. This is for system. Lift plus gravitational force on person. So gravitational force on this one is 100 Newton, lift, plus gravitational force on person is, this is 60. Okay, let's say this is 1000. Sorry, 1000, na? Yeah, 1000. So this is 1000. Gravitational force on lift is 1000 Newton. Gravitational force on person is 60 kg into 100. Sorry, 10. Because G equal to 10, let's say. So we'll get 600 Newton. So 600 Newton. Now it is 1600 Newton downwards. 1600 Newton. Fg is pushing 1600 Newton downwards. Lift is moving upwards with a force of 1050 Newton. Okay? Let's say it's not 1050 Newton. It is 1650 Newton, sorry. 1650 Newton. Then only lift can move up, right? Because gravitational force is more. External force here is the lift force, the force of the lift. 1650 Newton. So which force is more? Obviously we can say the force of or external force is greater than gravitational force. So therefore lift will move up 2.5 meters. So resultant force F net is equal to 1650 minus 1600 is equal to 50 Newton. With 50 Newton force, the system will be moved upwards of 2.5 meters. Let's calculate what is the work done. Okay, there is no space here. Please take a screenshot of it. I'll calculate the work done of it. Okay, we calculate here. Otherwise, of the physics and unit 3 part. So we know work equal to Fs cos theta. Here cos theta is what? What is the resultant force? Upward direction. What is the movement? Is also in upward direction. So theta is 0. So cos theta becomes 1 anyhow. So Fs. F is 50 newtons in upward direction and S is 2.5 meters. So 50 into 2.5, how much? That is 5 by 2, right? 50 into 5 by 2. This is 25. 25 into 5, it's 125 Newton meter. So work done is nothing but 125 Newton meter of work done by what? By the external force of the lift pressure on the system. So this is the problem, very classic level of problem. It is asked in advance also once upon a time. I think it's some from 1998 advanced paper 2 of physics, I think. So they asked such kind of problem related. So I don't remember exactly what's the problem. So it's some kind of related problem. So please take a screenshot of it. It's very classic level of problem applied to all kind of classes as well as all type of theoretical lectures and problems also. Like you can take this as solved out example and please take a screenshot of it, very useful. Okay, so this is what about the work done and the solved out problems. So here we have seen any kind of queries or problems or any kind of suggestions or much more information, doubts, please mention in the comment box. I'd be allowed to share that answers, and also I'll always be approaching you at a faster rate. So this is your Vignesh from your Mr. Vignesh tutorial signing off. Until then, bye bye.